Hey everyone, my name's Chad. This is the step-by-step guide for a project that I wrote, deploying Apache NiFi secured and auto-scaling cluster in AWS. We'll use Terraform to automate the deployment with Ansible behind the scenes, and the project supports either RHEL 7 or Ubuntu as the base operating system for the cluster. Requirements: you'll need at least an AWS account already, and it's helpful but not necessary to have Terraform already installed. If you don't have Terraform already, I'll walk you through it. Though, note I'm using a Windows, this is basically a blank or brand new Windows installation on my local machine, and then I'll be installing Windows Subsystem Linux to actually run Terraform. Keep that in mind. So if you've got Windows at home or at the office and you need a Terraform environment, this first 5 minutes or so of the video will be the prerequisite to install Terraform and get that up and running. Let's get started. I'm at the GitHub page, and I'll scroll down to the step-by-step Terraform deployment guide. So for Windows users, we're installing Windows Subsystem Linux. The very first step is to launch an elevated PowerShell prompt, and we do that by finding PowerShell, right-click, and run as administrator. We're prompted, I'll say yes, move this over a bit, and the very first command, copy that and right-click to paste in PowerShell. Windows Subsystem Linux has been enabled. You'll notice there's a no restart flag. If you've never enabled or used Windows Subsystem Linux on this Windows machine, the machine needs to be rebooted. Go ahead and do so now. That's the next step. I've already done it. I don't need to reboot. And then after, we'll need to launch a regular PowerShell prompt. We don't want to proceed with the elevated prompt any longer. So I'll launch a regular prompt and move it over. Next, we download Ubuntu. That's the Windows Subsystem Linux operating system we'll be using. Give this just a minute. It won't take too long to download. I'll be back when it's done. The Ubuntu package finished downloading. We need to rename it from .appx to .zip. And then we expand that zip into a directory. Change to the directory that got expanded and run the installer. This installer is going to prompt us for a username and password, and I'll be back for that. It should just take a moment or two. Okay, that took, I would say, about 2 minutes, and this is a virtual machine. Didn't take too long. We're asked for a username. I'm going to keep it simple, and my Windows username is Chad, so I'm going to stick with that and use Chad. And then password, make it something memorable. Type it back in. You will need that password in just a moment. All right, so we're in Windows Subsystem Linux. It's been installed. If you ever close this window, need to get back in, open PowerShell, and type in WSL. One other step I like to run is to cd and then tilde or the squiggly line. That changes directory back to our home directory. And you can see that there, /home/Chad. And then exit with exit. Next, we install Terraform, Git, and create an SSH key pair. The first step for that is adding the apt key, and we're prompted for that password we just created. You'll need that password anytime you run a sudo command and you have not run sudo in a while. Then we add the source or the repository for Terraform. And then we install Terraform and Git. We can now use Git to clone the project. It's the same URL that's in the address bar. And then finally, we create an SSH key pair, a private key and a public key. It's going to ask us for a location. I suggest the default. Hit enter. It's going to ask for a passphrase as well. We're going to skip that for this round. And then hit enter the couple more times, and the SSH key has been generated. All right, so the local development environment is set up. We do need credentials for that development environment to talk to AWS, for Terraform to talk to AWS. So we're going to install the AWS CLI, and we're going to create a non-root AWS user if you do not have one already. All the AWS CLI, we need a couple things. We need Python 3 pip. So we'll run this command, Python 3 pip has been installed. We'll use pip3 to install the AWS CLI. I've already pasted that command in, and you can see it here. Give that just a moment to run as well. Done installing. I'm going to go through the steps to create a non-root AWS user. We'll need that because all of the resources, or all of them that are supported, are encrypted in AWS with KMS keys. We'll need a non-root user that has permission to access those keys. And this is the same user that's running the Terraform apply. So I'm going to show you the quick steps to do that. You might already have a non-root admin account that you can run Terraform from. That's okay too. You'll just need the credentials for those. So to create the user, we'll go to the AWS Web Console and then go to IAM users add user. So I'm already at the IAM console. We'll go to users, add user, and I'm going to name this NiFi Terraform. We need to check both programmatic access and AWS Management Console access. I'm going to set a password. Uncheck require password reset. Let permissions match an existing policy directly, and it's this very first one here, administrator access. And I'll do that. You could add tags if needed. Let's review it. The username NiFi Terraform. Access, we checked both of those boxes, programmatic access and console access. We'll need both. Programmatic access is for Terraform, and then the management console is for access to things like S3 files. And we'll create the user. It does have administrator access. Now this key and secret, normally you wouldn't show those, but for this tutorial I'll show it, and I'm going to show you that I'm going to copy it into PowerShell, and all these resources are going to be destroyed when I'm done with the tutorial. But normally you would keep this safe and secure and not expose it. So before I close that window, let's go back to the instructions. So we need to set the credentials in the Windows Subsystem Linux CLI. So I'll run this first command, paste that in. It's asking for the access key. That's that first value. Copy it, paste it in, hit enter. And then it's asking for the secret. Copy that as well, paste it in and hit enter. Default region name, you could certainly, if you know the region you're going to be using, it's a good idea to set this. If you don't, that's okay. I'll set mine. And then the output format, you could set that. I'm going to leave it blank. All right. Let's go back to our instructions. Let's validate the above steps were done correctly. We'll paste this command in, and we can see that my user NiFi Terraform was the one that ran this command. I've got my account number if I need it, and there's that user key, or user ID, I should say. Next, we're going to, so there's a special tool in AWS called SSM, Session Manager. It's a plugin, and we can use that to get access to our EC2 instances that are running NiFi without SSH. Kind of handy, and I'm going to install that in this environment as well. So we'll grab this command. Oops, let's try that one more time. Copy, we get this out of there. Paste it in, scroll back to the left, and install it with this command. All right. And then there's another step for Session Manager. Copy this entire thing from T to EOM, copy, and paste. That adds it to your SSH configuration. So technically it's an SSH session, but it uses Amazon's SSM Session Manager to get access to the instances. It's really cool, and we'll see that when once the cluster is deployed. I'll show you how that works. All right, so we're going to customize our deployment. In this case, we're going to use RHEL 7. You could use Ubuntu. And I've cd'd into the NiFi/RHEL 7 directory. And we're going to open the same directory in File Explorer. So copy this address and open File Explorer. In the address bar, paste it in, but you'll notice it says here Chad, replace that with your Windows subsystem Linux username. That's whatever username you set up when it was prompted you to. If you're not sure what that is, it's over here on the left, Chad, or type in who am I, and you'll see it there as well. So paste it in, but then replace Chad with whatever your username is. All right. We've got a whole bunch of files. These are all the Terraform files that'll deploy the project. And then we've also got nifi.tfvars. That's our variables file. That's the list of variables that we can edit to customize the deployment. Double click it and it's going to prompt you for an application to open it in. Notepad is fine. I've already done that. It's not going to prompt me. And let's scroll down to the variable section. There are a few that are super important. All of them should be looked at, but there are a few that are super important. The very first one at the top of nifi.tfrs is the profile. That's the AWS profile that Terraform will read your credentials from. And that generally is default. If you only have one access key in secret that you've set up, and we only have one, that's what we just did with that user in the AWS web console, the profile is the default profile. The region, you should set that here as well. I'm going to use US East 1. You could certainly use any region as long as it supports all the services, and most of them do. Next, we need the KMS manager. That's the username that we created in the console. And if you remember, mine was NiFi Terraform, so I'll copy that and paste it between the quotes. Next, we need the subnets that are permitted to browse NiFi. NiFi is generally a web UI application. So we'll need our IP address because we're using network load balancers, and that's how we restrict access to the web UI on top of a certificate, and I'll show that once we've deployed the project. So replace this with your IP address, whatever IP address you're going to deploy from, that you'll need access to it. If you don't know your IP address, you can type it in, Google, or Bing in this case. What is my IP? And there's mine, I'll grab it. And a /32 denotes a single IP address. So if you've got multiple IP addresses, you could put a comma and do a secondary set or third or however many you need, right? It's kind of nice. So I've just got a single IP address that I'll be accessing NiFi from. I'll keep it with this single entry. There's also subnets for sending traffic to NiFi. So let's say you're going to set up NiFi to listen on port 443, or you're going to send UDP traffic to it, or TCP traffic to it. You could define clients that will send traffic to the NiFi cluster. If you don't have anything, you can certainly leave it blank. That's okay too. Or if you could also set that same IP address, your management IP address, you could set that here as well, right? So if you ever use NiFi to listen for incoming traffic, this is where you would permit or deny access. Only things that are defined here will be permitted to reach NiFi on the service ports. Speaking of ports, the very first one to define is the web port. By default, it's 2170. You could set it to something else. Keep in mind it should be above 1024. NiFi is running as a non-privileged user, the service, on the Linux EC2 instance. So I would suggest keeping it above 1024. In this case, I've got it set to 2170. That's fine for me. And then, speaking of the service ports, you can define them here. So if you've got, if you have in mind to use NiFi for traffic from TCP traffic or UDP traffic, you could certainly define that now. And I'll leave it at, I've got some examples here, 2200, 2201, I've got designated as TCP ports. For UDP, I'll do port 9999. And then there's also TCP/UDP ports where it could be either protocol. And I'll set that up as well, 9998. And you could leave all of these blank, that's okay too, if you don't have any intention of sending traffic to NiFi. Next, a public SSH key. If SSM fails for whatever reason, right? That's the AWS service that I mentioned earlier. Let me go back to the instructions. The SSM Session Manager plugin. You could SSH to the instance directly. You would need to set port 22 as a service port for TCP, and that would allow SSH, right? SSH is running on port 22. And you would use your SSH public key. The SSH public key is the key that we generated earlier, and you can get that value with this command. We want the public key, so that's the one that ends in .pub. To copy out of Windows Subsystem Linux, you highlight, then right-click, and now it's on our clipboard, and in between the quotes, we'll paste it in. Right, so there's an option as well. You don't necessarily need to set it. You could just leave it as that key, that fake key or false key, or set it to something that you'll never use. But it is kind of handy to have a backup option in case AWS SSM Session Manager does not work for whatever reason. You would need to define port 22 for TCP to allow inbound to the instances. Next, we need to set up or set the instance type. By default, it's R5.large. That's pretty big, though you'll need at least 2 gigs of RAM for the machine, and I believe that's a medium, right? So I think, theoretically, T3.medium or T3A.medium, if you're okay with a bit slower of a CPU, should be fine. For now, I'll leave it as R5.large. This also does have an effect on the initial startup time of the cluster, and any time the cluster is going to scale up. Keep that in mind. NiFi is a bit RAM heavy, so if you're going to play around with it, maybe take a look at those the values for memory, how quickly the cluster stands up, that sort of thing. It does take about 15 minutes with an R5.large. Next, we set the size of the disk for each of the instances. 15 gigs is fine if you're not going to store anything. That works. If you are going to use the local storage on the instances, you might want to increase that to something higher. The minimum and maximum node count. This is, so when we deploy this service, there are 3 Zookeeper nodes. These are nodes that are running NiFi, but they're also running Zookeeper for cluster management. There's 1 in each of 3 availability zones. And then you can add, via scaling, any additional number of NiFi nodes. That they're not running Zookeeper, but they are running NiFi. And this is where you would set the minimum and maximum. And they scale based on CPU load. If you only want to stick with just those 3 instances, that's okay. The 3 Zookeeper and NiFi node instances. You could keep this as 0 and 0. I'll set it to 1 as my minimum and my maximum. So I'll always have the 3 Zookeeper / NiFi nodes and then 1 additional NiFi instance. Next, we have a name prefix. This is a label applied to a bunch of resources that are created in AWS. It's tf-NiFi or Terraform-NiFi. You could set it to whatever you want. It does need to start with a letter, and then I would suggest keeping it short. So maybe NiFi 1, right? If you had more than one cluster or something along those lines. Next is the AMI. This will grab us the latest official RHEL 7. If you want to use a different variant, this is where you would change it. We use CloudWatch to store the logs of the EC2 instances and of the NiFi application. This is a bit self-explanatory. How long do you want those logs to stay in CloudWatch? The default is 30 days. Next, which NiFi version and Zookeeper version do we want? I generally suggest, this is wrong, it's not downloaded from there. Which NiFi version and which Zookeeper version? I'm going to leave it as default. That's the current versions available on the repo mirrors right now. And then it needs to match these URLs, which is the mirror where NiFi and Zookeeper will be downloaded from. Next, we have a VPC or some network settings. Everything is deployed within its own VPC. And there are 6 subnets. There are 3 public-facing subnets and 3 private-facing subnets. The public-facing subnets are for the network load balancers, and then the private-facing subnets are for the EC2 instances that are doing the clustering. You could make this bigger and do, say, a /23 or larger. Just make sure it doesn't overlap something you've already got in AWS, especially in that region. Or maybe even account-wide, right? If you've got a whole bunch of resources already running in AWS, make sure this doesn't overlap with those, or anything else you've got running if you're doing this in a corporate environment. This should work for me. I don't have anything that's going to overlap right now. And then finally, because this is RHEL and Red Hat Enterprise Linux, when you create an AMI or copy an AMI from Red Hat and put it in your own account and encrypt it with your own keys so that you have a stable version to work from, you must make a copy of the AMI via deploying it as an EC2 instance, shutting it down, and then creating an AMI from that shutdown instance. Terraform does that for us, but we need to give it an IP address. And I've already defined it here. You would want to make it from one of these IP addresses in Prynet1's CIDR. All right, so I've already done that. Just keep that in mind. Once we're done, save the file, close it out. Let's scroll back down. So we've edited the file. Let's make sure we're still in the right directory. We are. We'll initialize Terraform. This is going to tell Terraform to download any code that it needs. And you'll notice there, AWS Random Time and Archive. Those are some of the Terraform providers or libraries that we need. It's pretty quick. And then we'll run Terraform apply. This is where the magic of Terraform happens. It's going to read through all of the code. Let me just show that. Right, so there's a bunch of Terraform files here. Things like IAM, KMS for encryption, a couple Lambda functions. One of the Lambda functions gets NiFi from those URLs that we defined in our vars file. There's a there's a Lambda for when a node scales down. The network load balancers. Yeah, there's an S3 bucket. All the things for auto-scaling. All of that Terraform code is now deployed when we run this apply. It's actually going to give us a plan first. And we'll see that in just a moment here. And there we go. We can see all the resources. There are 143 resources that are going to be created. If you scroll up, you can take a look at those. I'll type in yes. And we're going to give this some time to run. Terraform will now tell AWS to create all those resources in the order that they need to be created. One thing to note, because of the AMI, it's going to take a little bit of time. I've seen it take as little as, say, 5 minutes, and I've seen it take as long as 25, 30 minutes. Just depends on how busy AWS is at the time. It's usually less than 10 minutes. Very end, though, when Terraform has completed, we'll get some output that's going to give us a whole bunch of handy links. Things like where the logs are located for troubleshooting if you need to, or the Ansible output. Remember, Terraform is deploying all the AWS resources, but Ansible behind the scenes is configuring the EC2 instance. And we can see the progress, we can see if it's completed or not, with the URL that Terraform is going to output at the end of this. So we'll give that just another few minutes. And you can see here we're waiting for the instance so that that clock begins, where it just takes a little bit of time. Terraform has completed and we have some output. I'm going to scroll up just a bit here. And there we go. We can see at the end, apply complete. 143 resources were added. All right, and if I scroll up a little bit, somewhere up here, we should see the AMI. And there we go. It took about 12 minutes and 7 seconds for that AMI that I was talking about. If you ever need to make any changes, let's say you didn't set up any service ports and now you want them, you can edit that vars file again and then rerun the Terraform apply. And that will tell it make any changes that it needs. Keep in mind when you run Terraform apply, it goes through and will before the apply happens, you get that prompt to say yes or no. Always review what Terraform is planning to do before you hit yes. For example, if you change that name prefix now, it will need to delete several things and recreate them because that name can't be changed once the resource is created, right? But things like service ports, those are okay. Those you can do. And I suggest having maybe a development environment and a production environment or testing every now and then if you're going to need to make a change, and always review what Terraform plans to do. It'll tell you if it's going to delete or modify any resources. All right, so we've got our output, and we'll start at the top. First thing is a little disclaimer. NiFi can take about 15 minutes to initialize a cluster. It can take longer if you use like a T3.medium. That might take a bit longer if you use a R5.large, which is what I think I was using. That should take around 15 minutes or so. The state manager association, that'll show status complete, and then the network load balancer target group will show status healthy. And we have some links to those as well. So the State Manager Association. This is, first things first, actually, before we go into it, we need to be logged in as this user, this NiFi Terraform user that I created. So I'm going to log out. You might have already been root or some other IAM account. You'll need to be the account that you created that has administrator access and is what Terraform used to deploy the service as. So let me sign out and sign back in. There we go. All right, and then I'll grab this URL. Again, highlight and then right click to copy to the clipboard. And we can see success, right? And that's what we were looking for. Success or completed. And it is done. So those are the 3 Zookeeper instances. You could also check, if you go to State Manager, you'll see we have the Zookeepers, right? There were 3 of those, and then I set a minimum 1, maximum 1 for the node, and that node is still pending. So that's still being built. Give that a little bit of time. If these ever fail, you can review the logs. So if I go to execution history, look at that execution, there was only 1 because it's only been run once. And then the output, I'll just pick one of these instances. Scroll down to output, and you can look through. Now this will truncate, and it shows here it recently got increased, but it's still not enough. It'll truncate at 48,000 characters. You can see that because it's longer, there's a link for Amazon S3. So I'll click that, run shell script, and there's standard out, which is really what we want. You can see that's a pretty long one, so I'll download that. This is the Ansible playbook that ran that set up NiFi for us, that secured it, set up the whole clustering, all of that. And there we go. The file's been downloaded, and we can see this is the output from Ansible. Quite a lot of it is things like downloading packages, setting up KMS, that sort of thing. And if we look at the very end, we can see in this case, there was that success or complete message, failed equals 0 is good. But you could use this to troubleshoot if you've got something that fails to start. All right, we don't need this S3 anymore, or this. What else do we have? Our target group. This is the network load balancer, specifically for the web UI. There are 2 load balancers. There's one for the web UI, which the 3 Zookeeper instances that will always have, that's what they're attached to. And then there's the service load balancer, which the 3 Zookeepers and any additional nodes. In this case, I only have 1 additional that is attached to. So we'll look at the load balancer, and we can see all 3 are healthy. That means that NiFi is up and running, and we should be able to connect to it. Additionally, there are logs. So I will right-click, copy. Let's look at those logs. And you can see the instances. We can sort it. So there's Zookeeper 1, 2, and 3. And then the fourth is the instance that got created, the fourth node, the non-Zookeeper. And we have, in the case of rel 7, we have varlog secure and varlog messages. In the case of Ubuntu, it's varlog syslog and varlog, I believe, auth. I can't remember off the top of my head. And then in both cases, you'll have the NiFi app log. We'll look at one of those. And we can see all of the logs from the NiFi app. And you can expand these or download, etc. Good for troubleshooting. What else do we have? The admin certificate and secret. In order to access the cluster, because it is secure and we're not using something like LDAP authentication, we use certificate-based authentication, which means the client or our browser has a certificate installed that is trusted by the NiFi cluster. We can get that at this URL. And we'll also need the password because it is password protected. Let me refresh. You are not connected. Come on. There we go. And we'll download the key store. That's the certificate. And we'll download the generated password. So I'll open the password. Again, this is a password, and it is randomly generated. This isn't something you'd normally want to expose. All of these resources will be destroyed. And I'll open it in Notepad. They'll all be destroyed when I'm done with the tutorial. So I've got the password. And then if I go into, this is Edge, because this is, I don't even have Chrome installed on this machine. So I'll go to certificates. Chrome, it's a little bit different. Firefox, it's a little bit different. But generally the steps are similar. Go to import. We'll find it. All files. There it is, key store. Copy and paste the password in. Sure. Import was successful, and there we can see issued by TF951. Okay. What else do we have? Now that we've installed the certificate, we can visit the web UI. So I'll copy that, paste it in. Your connection isn't private. Again, these are self-signed certificates. That's okay. It's to be expected. We'll continue. It's going to ask us which certificate to use. There's only one. In my case, I'll hit OK. And we are in NiFi. All four of the nodes are connected. If we look at the cluster, we can see the three Zookeeper nodes that are always connected, and then the fourth, which is the, in the vars file, minimum one, maximum one, which just really means always one additional node. We can see that node here. That's the fourth one. And you could have just the three Zookeepers. That would be okay as well. One thing I'll note, there is no ability to set up any processes or process groups. When you have a secure cluster, you'll need to edit the policies. And we can do that easily enough. I'm going to go through that real quick. So let me start that over again. You right-click anywhere in the blank space, manage access policies, and right now we're selected on view the component, and you'll notice there are no users and there's no policy. So we'll create a new policy. We'll add the user, and it's admin. And then we'll modify the component, policy, create, admin again, and operate the component. Create, admin again, close that out, and you can now create processors and do everything you'd want to do with NiFi. We have our cluster up. We could scale it back down as well. That's another option. So we've got the 4 nodes. Maybe 4 was too much. I didn't need 4. We could scale that down. So if I go into my NiFi.tfrs file, you could do this via the console, via the AWS console. That's one option. Actually, I'm going to do it through Notepad. You could do it through the console. Just keep in mind that whatever is set in the console, if you changed it outside of Terraform, Terraform is going to revert it back if you ever run Terraform apply again. So I would stick with Terraform. That may not be your style, and that's certainly okay. Do whatever you please. But if you were to ever, let's say you changed your scaling from minimum 1, maximum 1 down to 0 and 0, and you ran Terraform apply for something else. Maybe you opened a new port, but your minimum and maximum were set to 1. It's very possible that Terraform would go and change the AWS again to match what's in Terraform. So just keep that in mind. So if I go back to my vars file, I'm gonna do 2 changes. These are both safe changes. They're not going to destroy everything. Like I said before, the name prefix, that applies to a lot of resources that have to be destroyed in order to be recreated with a new name. So that's one of the prefixes you wouldn't necessarily want to change. Another is the AMI, right? The cluster is based off of that AMI. You could change it, but it's going to recreate that AMI. And remember, that took like 10, I think it was like 12 minutes for me, and it could certainly take longer. So it may be a good idea to leave that alone. Anyway, min and max were 1, now 0. I'm also going to add an additional port. Let's do 2202 and remove SSH because we're going to use SSM. So I'll save it, close it, and we'll run apply again. Let's go back. We'll grab this. This should be pretty quick. Again, last time it took like 12 minutes because it had to do things like it had to create all the resources. None of them existed. This time, because there's so few things changing, it should be pretty quick. And we can see this time there are 2 things that are being added and 5 things that are being changed. And if we look, security group rules are being replaced because of the ports. And if we scroll up high enough, we should see, there it is. Min and max are going from 1 to 0. So I will type in yes. While we're waiting, let me open a new Windows subsystem Linux window. CD back into NiFi, rel, and I can run Terraform output. That's going to give me the output that we saw at the end. If you ever, I would suggest, by the way, keeping a copy of this, maybe storing it in a text file somewhere. But if you ever need it and you don't have it, you don't want to run Terraform apply, Terraform output will give it to you. So if you ever need to troubleshoot or you want to do something in the console of the instance, you can do that via SSM start session. If you need the instance IDs, I've provided a AWS CLI command that will give you a list of them. Whoops, there we go. So we run this, we can see the 4 instances, one of which will be going away soon. And then if you want to connect, here's the command to connect, and then just replace that last little bit with the instance ID. So we'll go to Zookeeper1. And here we are, we're in our shell. If I type in who am I, we'll see that we're the SSM user, and he doesn't have a ton of permissions, but he can sudo. And we'll give that just a moment. There we go. And we are now logged in, just like SSH, but without using SSH. We're not using that port. We're doing it via AWS SSM. And you can make changes as needed, run top. Really handy. So now we have a way to get into the instances, troubleshoot, make changes, develop, test without SSH exposed. Really nice. We can see the instances running. I type in status NiFi. We can see NiFi is running. Same thing with Zookeeper. Though Zookeeper would not be running on any node instances. Exit with exit. And you can exit Windows Subsystem, Linux, and PowerShell as well. All right, what else do we have? Let's try. Actually, let me open another backup. If I go back into, because I don't remember the service ports that I used, and I look at nifi.tfvars, we had to find some service ports, 2200, 2201, etc., and UDP as well. I'm going to set up a listener real quick. Listen TCP. Let's do this. And we will set the port to 2200. Leave everything else the same here. This is fine. Actually, I need to do one other thing. We're going to automatically terminate it. We'll start it. We're going to get a little message about the buffer size not being set. You could certainly change the buffer size on the machine if you needed, or add that to your playbook, whatever it is you're going to do. But we are now listening on port 2200 on all of our NiFi instances. And because, scroll back up and show this, because client-siders, we define my home IP address, I should be able to reach the service on 2200 using the service network load balancer. So if I type in Terraform, I don't have it here, Terraform output, and I get the service ports, I should be able to do something like telnet on 2200, and we're connected. And if we watch, we should start getting some traffic in. Let me refresh it, and there we go. We got 17 bytes. So you can see that we have access to NiFi on that service port. Just keep in mind the web UI is one of the load balancers, and I have them, they're distinguished in the Terraform output. So we have the web UI, which is the 3 Zookeeper instances, and then we have the network load balancer service ports, which are all the service ports. And the reason there are 2 different ones is because you might have management where you're connecting to the web service, the web UI, from one set of IP addresses, and the service ports are a different set. And that's just a useful way to distinguish between the 2. All right. One last thing before I go. So we modified the min and max value and ran Terraform apply on the number of nodes. That change finally happened in AWS. It took a little bit of time, but you can see if I go into EC2 Autoscaling groups that only Zookeeper 1, 2, and 3 have instances. The 4th, which is the nodes Autoscaling group, is now sitting at 0. And if I look at NiFi, the web UI, you can see we've dropped down to 3 out of 3. And if I hover over the this little error box here, or notification box, there's a note there that the 4th node has been removed from the cluster, right? So that's part of autoscaling. When autoscaling occurs, when it scales up, most of that is done through the Ansible playbook. And there's like a scale up script where the node will add itself to the cluster. Scale down is a little bit more complicated. I'm probably going to do a deep dive into some of the inner workings of that, but I think for this video, it makes sense to kind of stop it here. Thank you, everyone. Have a great day. If you have any questions, comments, concerns, I have a Discord channel that I'm on pretty often. I'll link that in the description of this video and on the GitHub page. If you open a GitHub issue, that's okay too, or a discussion, that's fine, or leave a YouTube comment. The best way to reach me, especially if you have questions, troubleshooting, setting up the service, Discord is the best way to reach me. Thank you, and take care.